Video, I will go over exponential growth and decay and how to find the equation of an exponential function when given pieces of information. After finding the equation of an exponential function, you can find the unknown. So this is you've probably seen exponential growth and decay in pre-cal and college algebra. So this could be a review, but this will be again in calculus too. So yes, what is an exponential growth and decay? When the rate of change varies exponentially, we use the term y equals c times e raised to the kt. Okay, so yeah, if you ever hear the word exponentially, you know you're going to use this formula right here. Okay, so how do you get that equation? Well, there's some steps. So what you want to do is in a word problem, what you want to do is write down your given conditions. Sometimes they'll give you an initial condition, and sometimes they'll give you a final x, and we got to find the y, right? Then what you want to do is solve for c. C is the initial condition. Yeah, and then step 3, solve for k, and then step 4, solve for the unknown. So yeah, let's do an example. So example 1 says, a colony of bacteria grows exponentially and the population is 1,000 at the time t equals 0 and 5,000 at the time t equals, that's not right. That's not at time equals 4. This is a mistake. And 5,000 at, wait, and yes, and 5,000 at the time. Yeah, I actually, this is right, 0. I'm just rewriting it. So a colony of bacteria grows exponentially. The population is 1,000 at time equals 0 and 5,000 at time equals 4. No, this is right. This is wrong. And 5,000 at time equals 4. So I'm just I rewrote this twice. How big is the population when time is 9? So yeah, what we're going to do first is step 1, find the so I'm definitely going to use the equation y equals ce kt, and then I'm going to so step 1 would be use first condition to find c. So yes, so we said our initial condition when at 0 it has a population of 1,000. So that's a coordinate. T is like your x, right? And then y is your population. So you can write it as a coordinate if you like, 0, 1,000. And then let's just write out our other conditions. So they're saying that at 4 seconds, the population is 5,000. So that's growing really large, right? So 4, 5,000. Okay, so what I'm going to do is you plug in this coordinate into this equation, and then that will give you your c. But I believe the c is going to be 1,000 because, yeah, you'll see why. So plug in y for 1,000, right? Equals c. We don't know what c is, and then e raised to the k, and then our time is 0. So this is going to be c e, and then k times 0 is 0. And what's e to the 0? Anything raised to the 0 is 1. Times it by c, and then your c is 1,000. So your initial value is 1,000. So it's going to be y equals 1,000 e to the kt. Okay, now then what I would do is use the second condition to get K. Okay, so our second condition is 4 comma 5,000. At 4 seconds, it has a population of about 5,000. Okay, so now we're going to plug that back into this equation. Okay, replace y with 5,000. And then replace our time with 4. So it's going to be 4 times k. Okay, so we're going to solve for k then. So what I'll do is get rid of this 1,000 by dividing both sides by 1,000. This cancels. And then you're left with e raised to the 4k. 5,000 over 1,000 is 5. And then what we're going to do next is solve for k. So how do I solve for k? Well, there's an e, so there's a good chance. Well, I'm going to take the inverse of e, which is ln. So I'm going to take the ln on both sides. So on the left, it'll be ln of 5. On the right, ln of e to the 4k. Uh, ln and e are inverses, so this cancels or it really just becomes 1, and then you're left with 4k. So 1 times 4k is 4k. Over here, let's just leave it as ln 5 and solve for k. So you're going to divide this by 4, and you get k equals, oops, why did I put a k here? 4, ln 5, 4. Okay, so we know our k, we know our c. Now, step 4, find your final equation. Wait, no. Well, I need to find my final equation, and then we can plug in our final uh, condition. So what's my equation? It's going to be y equals c e raised to the kt. And I know that my c is 1,000. E, and then our k is this whole thing. I'm just going to leave it as is. It is a decimal. If you put ln of 5 over 4, it is it's about like 0.40. But I want to be very specific, so I'm just going to use the exact value. So y of t of 1,000 e, and then our k is ln of 5 over 4 times it by t. Okay, so that's not our final answer. The final answer, they're asking, what do they ask? How big is the population at time 9 seconds? So we want to find the y value, right? So let's just plug in 9. So this would be ln of 5 over 4 times by 9. Okay, and this is your answer. You can leave like this. If you want a decimal, what I would do is simplify the power first. So ln of 5 over 4 times by 9. Let's see. So ln of 5 over 4 times by 9 is like 3.62. So this could be 3.62 and then 1,000. Okay, and put that in the calculator, and you get 37,337.57. Okay. If you want exact value, it would be this. So in, what is it, 9 seconds, its population grew to this. Um, I would probably round it to whole numbers because you can't have a 0.57 population. So maybe like 3733. Should we round to whole numbers? I guess so. So yeah, this amount. But if you want exact value, this would be the final answer. Okay. Let's move on to example 2. Okay. Example 2 says a radio element decays exponentially proportional to its mass. One half of its original amount remains after 4,200 years. If 100,000 grams of the element are present initially, how much will be left after 20,000 years? Okay, so we're definitely going to use y equals c times e to the kt, right? And let's write out our known values. So let's first find out c by plugging in your initial condition. So they're saying that at zero, if 100,000 grams of the element are present initially, so that actually gives us your C value, right? So they're saying at time zero, it gives you Y of 100,000, 100,000. So yeah, you don't even have to plug it in. If you plug it in though, you'll see that C is 100,000. But if you want to plug it in as a coordinate, so remember T is like your time is your X and your Y is their time. I mean your amount. So if you put that back into this equation, K times 0 is 0. E raised to 0 is 1. 1 times C is C. As you can see, this is 100,000. Okay. So our initial condition is our C value is 100,000. And then what else is our other values? Uh, mm, so what are we trying to find? How much will be left after 20,000 years? Um, so yeah, that means we're trying to find the Y value, right? So we're trying to figure out the population after 20,000 years. So this T or X value would be to 20,000. So 1, 2, 3, 4. And then our Y is unknown. Okay. So we know our C. Um, oh, they also say that one half of its original amount after 4,200 years. So at 4,200 years, uh, what's one half? What is the Y population? If 100,000, what's half of 100,000? 500,000, right? Or no, 550,000. So Yeah, so at 4,200, it spits out 50,000. Two, three, four. Yes, that's 50,000. Okay, so now what we're going to do is find our k value by plugging in this value. So my y value would be 50,000. And wait, what our time was 4,200. So it'd be 4,200 times k would be 4,200k. Okay, so go ahead and solve for k. So divide this by this amount. And then all these zeros cancel, so you're just left with 5 on the left. This cancels, and then you're left with e to the 4,200k. And then go ahead and solve for k. So you would have to take the ln of both sides. So ln 5. Here, this is ln of e to the 4,200k. And then the ln e cancels, and then you're just left with 4,200k. And then over here, you have ln of 5. And then solve for k, so you divide this by 4,200. And you get k equals to ln of 5 over 4,200, right? Okay. Did I do this right? No, I did this. This is 50,000 divided by 100,000. So that's actually one half. Why did I say 5? So I kind of messed up on this algebra. This should be one half. And then this 5 should be one half. Okay. And so that's our k value. We'll just leave it as exact value. So our equation is going to be y equals 100,000 b raised to the ln of one half over 4,200 times t. Okay, and then what they're asking now is how much will be left after 20,000? So you just replace t with 20,000. Okay, you could put that in the calculator as a decimal, but this is perfectly fine as an exact value. Okay, go ahead and copy and do example 3. Sample 3 says a radioactive element decays exponentially proportional to its mass. One third of its original amount remains after 100 years. If 3,000 grams of the elements are present initially, at what time will there be 250 grams left? So this time they're asking, what are they asking? At what time? So they're asking for an X value when they give you a Y value of 250 grams, right? So first step is find your C. Right? Find your C. So step one. Find C. When your initial condition is if 3,000 grams of the elements present initially, so yeah, you don't even have to plug it in. If they say initially, that is your C value. So your C value is 3,000. If you want to do it as a coordinate, it would be when time is 0, Y is 3,000. Okay, so go ahead. If you do the work, you'll see that C is 3,000. So it's going to be Y equals 3,000 e to the kt. Okay, step two is find your k by plugging in another known condition. So they're saying that one third of its original amount remains after 100 years. So when c is when the time is 100, what is one third of 1,000? Uh, 1,000, right? What is one third of 3,000? 1,000. So at y it would be 1,000. Okay, so go ahead and plug that in to get your k value. So replace y with 1,000. Your k is, I'm not sure, and your t is 100, so that's like 100k. Get rid of this 3,000, so divide this by 3,000. So you're left with one third e to the 100k. And then go ahead and solve for k. So there's an e, so you would take the ln on both sides. Okay, so ln e cancels, you're left with 100k. And then this is ln of one third. And then continue solving for k, so divide this by 100. So k is ln of one third over 100. Okay, now what are we trying to find? We are trying to find your unknown value. So we're trying to find an x value. We don't know what time, but they give us a value of 250 grams. So at what time will there be 250 grams? So they give you a y value of 250. So now that we have, so we got to find our final equation is y equals uh, did I make a mistake? I think I did. Oh no, I didn't make a mistake. So Yeah, so our equation is going to be, so our C value is 3000, E, and then our K value is ln of 1/3 over 100 times T. Okay, and then we go ahead and solve for T. So when the Y value is 250, replace Y with 250. Go ahead and solve for T, so divide this by 3000. I guess one of the zeros cancel, so you're left with 25 over 300. I guess this could be reduced by 25, so this is 1 over 12. 112 equals to E ln of 1/3 over 100 times T. Now, how do you solve for T? Well, there's an E, so there's a good chance you're going to have to take the ln on both sides, so go ahead. And then the ln E cancels, so you're left with ln of 1/3 over 100 times T. And then you have ln of 112. And so you want to solve for T, so what can you do is you can multiply it by the reciprocal of this, right? So go and multiply the reciprocal of ln of 1/3 over 100. That would be 100 over ln of 1/3. So this cancels. So you're left with T equals to 100 ln of 112 over ln of 1/3. And that's your T value. Okay. Okay. Let's do example 4. So a puppy weighs 2 pounds at birth, at 2 pounds at birth, and 3.5 pounds 2 months later. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its weight, then how much will the puppy weigh when it is 3 months old? So when they say increasing at a rate proportional, that's a good sign you're going to use the function y equals ce raised to the kt. So our initial conditions, so first find c. So they're saying so when it's first born, it automatically weighs 2 pounds. So at t equals 0, your weight is 2 pounds. So if you want to plug that in, you'll see that the c will be 2. So 2 equals c e, and then our k times 0, and then k times 0 is 0. e to the 0 is 1, so that's c equals 2. Okay, now what we're going to do next is, so it's going to be, and then our other condition is at 2 pounds, the puppy weighs 3 pounds. Wait, at 2 months later, it weighs 3.5 pounds. So we're going by months, not years. So in 2 months, the puppy will now weigh 3.5 pounds. So we're going to use that to find our K. So replace Y with 3.5. And our C is 2, E, and then it's going to be, what's our time is 2, so that's 2K. Solve for K, so divide this by 2, divide this by 2. E to the 2K. Then take the ln of both sides. So this is the ln of 1.75. This is going to be ln of e to the 2k. And then the ln e cancels, you're left with 2k. And then this is the ln of 1.75. Divide this by 2, divide this by 2. Okay, so that's your k value. Now we're saying, then how much will the puppy weigh when it's 3 months old? So at t equals 3, what is the y value? Not sure. So first we got to find our equation. So it's going to be y equals c, which is our c is 2, e, and then our k is ln of 1.75 over 2, and then our time is 3. So this could be your exact value. Yeah, so this would be your answer. That would be an actual value, right? Let's move on to the last example, example 5. So a population y grows according to dy over dt equals k times y, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is. So yeah, we're still going to use the same equation, y equals, this is an exponential growth. So we're still going to use y equals ce raised to the kt. So this time, this one is a little bit different. They do not give us a c value, right? They do not give us an initial condition, but they do give you in 10 years, uh, yeah, they don't give us an initial condition. So if they don't give you an initial condition, you're just gonna have to make something up. So make something up, something easy. Okay, so maybe when t equals 0, maybe the population could be 100. And if the population doubles every 10 years, so in 10 years, the population would be 2 times 100, because twice as 100 times 2 is 200, because it doubles every 10 years. So now we have two conditions. Let's find our c and let's find our k. Y equals c e to the kt. My y is like 100, c e, and then my time is 0. 100 equals C, E, and then K times 0 is 0. E raised to 0 is 1. So my C is 100. So it's going to be Y equals 100 E uh, KT. Now we're going to find our K by plugging our second condition, T equals 10 and Y equals 200. This is 10K. And then go ahead and solve for K. So first I'm going to divide this by 100, divide this by 100, and you get 2 equals E to the 10K. And then go ahead and solve for K. So you're going to take the ln of both sides. So the ln E cancels, you're left with 10K. Divide this by 10. You get K equals ln of 2 over 10. Uh, yeah, so they just wanted the K value, that's it. So this is your K value. If you want exact value, that would be like a decimal. That would be like 0.069. So yeah, that is your K value. Okay, so that is example. That was the last example. Okay, so next video should be about Euler's method. So we're going to stop here.